All right, feel free to start whenever you would like. Thanks so much for being here again, and um, we're really excited and just happy to, kick off this first ever, OMSCS hackathon.
Yes, for sure. I'm pretty excited to be at the hackathon as well. So today I'm going to teach everybody about an important visualization tool that you might want to incorporate right today in your hackathon project as well. So I'll go ahead, share my screen. Yeah, I think it should be visible now. So today I'm going to be talking about visualizing the future. That is, how do you empower data with Orange? Orange is an open source tool. We'll be looking into the importance of having data visualization as a part of your project, as a part of the work that you are doing, and also about a tool that you can very easily, with a very short learning curve, have it directly in your project as well. So I'm Drishti Jain, and let me share a little bit more about myself. So I'm a software developer, also a lot into the machine learning space. I'm a published technical book author. If you scan the QR code, it'll have all of my social media links, my book link, everything. And for the hackathon as well, there's a special, there's a wait list. If you want to get my book at a very, very discounted rate on Kindle, sign up there and then I'll be sending you an email when I do that. I'm a social entrepreneur, so I also run a nonprofit organization. We work in environment, education, and healthcare. I'm an international tech speaker. I love to share the knowledge that I'm doing with the tech community across the world. So I speak at a lot of international conferences at different parts of the world, sharing my knowledge, sharing the projects that I've done, and a lot more tips and tricks as well. I'm also a career coach. So I have an initiative called Skill Up with Drishti, wherein I help people to upskill themselves to grow in their careers. If they're looking at upskilling themselves in order to gain a desired job title, that is also something that I do. So feel free to connect with me later on if you wish to be in the space of upskilling yourself. And in the bottom, you will see my X/Twitter handle. So feel free to tweet about the talk, about your experience at the hackathon. And I'll also be there tomorrow to judge the hackathon. So I'm really excited to see the work that you'll do in achieving great things. And hopefully you'll win some great prizes. So let's get started with data visualization. So data visualization, what does it exactly mean? Is it just data that is visualized in the form of pie charts or bar graphs, or is it much more than that? So by definition, data visualization is the pictorial representation of information so that the user can analyze data quickly. You want somebody to understand what you're doing in a very, very quick manner. That is wherein you would want the person to have a way of looking at something in a glance and understand all the information that you are trying to convey to the user. That is wherein data visualization comes to be very handy. It is considered as the modern equivalent of visual communication. One way of communicating a large chunk of information is through a lot of reports, a lot of tables. But if you want a way to concisely showcase the insights from the data, that is wherein data visualization becomes crucial. It also gives you the ability to merge data from different sources. So you could have data, for example, you are working on a social media project. You could have data of user activity across social media platforms. Also, you could have some user data and you want to show some correlation between the two or merge the two different types of data together. You will be able to do that and still showcase the insights, the learnings out of the data in a very easy to understand visual form. The challenge that we try and accomplish through data visualizations are the challenges of big data. The challenges of big data, including the scale of data. In the current world, you have a lot of quasi-structured data as well. Quasi-structured data is clickstream data. So whenever a user is using any application, there's a lot of data about what is the time spent by a user on a particular screen. What is the kind of time the user spends on actually going ahead and looking at a particular post on the screen. So what is the screen time of a particular post? That helps advertisers gain a lot of insight. Or a user is clicking a multiple series of chain of strings. So you want to capture that data. All of that gets captured as quasi-structured type of data. And you would have your generic relational data as well. in the form of tables, structured, non-structured data. And all of this is increasing at a very large scale. So you want a way that you are able to incorporate the new generated data right inside your current models as well. And data visualization becomes a great tool to showcase that data. The velocity at which the data is generated, a single user, just consider your everyday scenario. You use a laptop or mobile, probably an iPad. If you have a few smart devices in your home, right from the thermostat to your electric fan, your electric light, your electric fridge, there are a ton of things which are generating data constantly. So the velocity of generating data is very high in the current world. Also the variety, the different forms of data. So different devices that are used, different kind of interactions a person would have on the same device would also generate a lot of different kind of data. So all of that becomes very, very important to handle when you want to make something which is reliant on big data. And all of these challenges can be tackled in a way that is easy to understand for the end user, very well using data visualizations. There are a few key components that you should consider when you are actually trying to create data. One is make the use of right colors. So for our eyes, colors are what help us distinguish very well between different kind of interpretations of data that we're trying to share with the user. So make use of colors such that it is able to very easily convey the message of your data that you're trying to show. Instead of having a grayscale representation of data, for example, you have a simple pie chart representation of data. If it is grayscale, it will still take a minute or so for the reader to understand how each section of your pie chart is distinct from each other. Whereas if it is very different colors, say red, green, blue, like very easy to distinguish within a second, it is easier to interpret. So use colors to your advantage. The second is to discover trends. Using data visualization, one part of it is to represent the information that the data is conveying directly. The second is to discover and display the insights, the trends that you're seeing in data. You would have like hundreds and millions records of data, but out of that, you might have discovered some trend. So you can show a progression in the form of bar charts, in form of scatter plots to show what is the trend you're observing in data. And this will be useful when you're building something like a predictive model to show what section of the data your predicted outcome would lie into. And how does that support the trend that you discovered in your data? So use data visualization to actually go ahead and discover different trends in data directly. It also helps to comprehend information quickly. If there's a clear distinction between two parts of data, that is what is going to help you to understand information quickly. You don't have to rely on a lot of background knowledge in order to understand data. The fourth and most important part is to identify patterns and relationships between data. So there might be interesting insights that you must have not thought of earlier that the data would give you. For example, consider that you are a raincoat making company or an umbrella making company. You might have had a general insight that when it rains or regions with higher rainfall are the places that you would see a boost in sales of your products because you're selling umbrellas and raincoats. But there might be additional insights from data that if it gets too sunny, if the sun is very harsh, even then your scales skyrocket. Or if there is some kind of a different trend going on wherein people want a particular color of an umbrella or a raincoat, your sales would go up. This can be easily identified with the help of visualizing the data. If you have visualized your data well, you would see these trends to be very, very distinctly visible in your data. With visualization, the most important part is to actually find the right balance. While finding this right balance, you want the visualization such that it is technology centric and engineering oriented, along with it being very human centric and design oriented. When I say technology or engineering oriented, it should be able to clearly showcase what kind of transformations did you apply on your original data set to achieve the smaller data set that you're displaying in your visualization. But it should also be such that it is you or a third person as a human is able to very easily understand, analyze the information. An interesting component also to add to your data visualization is the component of exploring data. You might want to give the flexibility to the end user to navigate different data sets. So if you have a big visualization, say of a scatter plot, maybe give the ability to the user to drag on or select a particular section of the data that is being displayed, and then see if they are able to modify the data or understand what exact data points are those data points among all of the set. That way, the user will be able to understand and play with your visualization much, much better, and it will make it more human-centric. And an overall general idea that I like to have in my visualizations, and I would encourage everybody at the hackathon as well, is to be able to communicate some sort of an understanding of the data. Now, this understanding of data can be what insight is the data trying to tell you, or it can also be what does the trend show as a prediction value. That is also something that you can showcase directly with your visualizations. So find the right balance and create visualizations to give the point that you're trying to make very, very easily to the end user. Um, Let's now see how do we interpret data about cybersecurity breaches across the US. Now look at this example. This is all of the data about all of the cybersecurity breaches of a data set, the different US state it happened in, how many individuals were affected, the type of breach, the breach start date, end date, everything. And now just look at this data for a second. Are you able to understand this data really well? Wasn't it very difficult to read? Were you able to interpret anything out of it apart from that it is a table which consists of just cybersecurity breaches? And you couldn't take out really any kind of information which was useful in this. Whereas if I just plot this data in a mosaic display, you will be able to interpret this visualization very easily. The color distinction based on the states that are there, the number of individuals affected, also the progression in color shows you information about the individual affected. This is so much easier to interpret. If I give you 5 minutes to look at this, you'll be able to make out some information about which state has more cybersecurity breaches. Whereas if I go to the slide before this, even if I give you, say, 10 minutes with the whole data set, it will be very difficult for you to come up with a concrete analysis of what the data is trying to tell you. So this directly shows you the impact and the power that data visualization helps in achieving when you're trying to build any kind of model, any kind of project. And you might be wondering what exactly are the key concepts I should think about while making a good visualization. While creating a good visualization, the most important part is to have the information. Your information, you need to pre-process this information. It could be removing any unwanted bias, handling any kind of incomplete data in your tables. Do you want to remove it? Do you want to use some methods like mean, median, mode to calculate the missing values? And any other modifications, taking out a subset of it relevant to your use case, all of that happens in your data processing stage. And that is the very first part of making a good visualization. Then you should think about what is the concept, what is the story, what is the interpretation the data is trying to tell you, so that you know what you should focus on more than something else. Then you should have a clear goal defined. It might be possible that looking at the visualization, you come up with some new interesting insights, but you should also have a fixed goal before looking at a visualization as to what are you trying to understand out of it. What is the base function that you're trying to understand from your visualization? And the last but not the least is the visual form. What would be the best way to plot your data? It could be a mosaic display, a bar chart, a pie chart, a scatter plot. What is the visual form that will enhance the information you're trying to tell through your data visualization the best? So using these key points, you should be able to create a very, very good and communicative visualization. Whenever you're creating a visualization, keep in mind the main task you have is to enlighten or see the data in context of the use case that you're using the data for. The same data could be used for a number of ways. If it is census data, that is population data, it could be used to understand population growth in a country. It could be used to understand income levels in a country, or it could be used to understand the population concentration across regions. If one city has a higher population density over the other. So what is the use case you're solving for? The data could be used for multiple ways. So have the data in context and then use it for visualization. And your goal should be to highlight that data in context. You should be able to illustrate and hide data. So by this, I mean that if you are focusing, say, on population density, you would not want to focus on buying habits of people in a particular region because you are trying to understand the population density. So things like this, what is the data that you want to hide and what is the data that you want to highlight? That is an important distinction to keep in mind while creating visualizations. And also, you might want to use data visualizations to make comparisons between statistical data or even to predict outcomes. So you might want to see the progression in data through your visualization and also have your model support the next predicted value or value set to be continuing the same kind of progression with visualization. It is a good way to reinforce what you built and show that it is accurate. And the key reasons why visualization matters a lot, it is that it helps to make better decisions. You will be able to understand, interpret, and then decide on the future predictions of the data. Also, it will be a lot of meaningful storytelling. When you're trying to create a 360 picture of the use case or the project you're building, you would want to have a meaningful storyline. And visualization helps the end user to understand that story that you're trying to convey very easily. And also data literacy. For example, you are building something related to, say, finance or insurance, and the end user you're presenting to comes from a healthcare domain. They would not know the nuances of the finance or the insurance domain. But if it is in a visual manner, it is easy for the person to get literate on the data that you're working on, to understand the data better. So it helps with data literacy quite a bit. And with visualizations, you would also encounter places where your data is biased. You might see a lot of outliers, and then you would want to analyze why are those outliers there? And if those outliers are there, is there some kind of bias which is creating those outliers? Or there might be some kind of an unconscious bias that you would have while developing the model. And during the visualization, you would identify that. So use data visualizations to overcome conscious as well as unconscious bias. So with unconscious bias, the main thing is that it is basic judgments that you might have across different set of data points. This could be related to uh, ageism, casteism, racism. It could also be based on income disparities. So this is something that you might not be intending to do, but it would unconsciously be there in your thinking process. But the main part in order to overcome unconscious bias is that you need to be conscious that you might have unconscious bias. Once you make yourself aware that you might have, if you're conscious that you have unconscious bias, then it is very easy. You just need to remove the unconscious bias that is there. So it is very important to take conscious decisions to overcome unconscious bias. And so it is time to tackle unconscious bias consciously. And with that, let's dive into the interesting, very, very important tool that is Orange. So Orange is a open source machine learning and data visualization tool. Orange.biolab.si is the official website wherein you would find a link to their GitHub repo. You would find a link to the library documentation, as well as the web application of Orange as well. So with Orange, it is all about data visualizations, which help you discover hidden patterns. They also help communicate between data scientists as well as between domain experts. If your team, say in the hackathon, comprises of a few people who are good with handling data and other people who have the domain knowledge which is required to handle the data, then Orange becomes a good bridging tool for you in order to achieve the same. This is how a workflow in Orange looks like. It is about combining different widgets in a workflow, which enables you to build very, very comprehensive data analysis schemes as you go. And with a large library of widgets, you won't have to be constrained by choices. There are a lot of widgets that you can choose. It is a component-based data mining tool that you can use. So if you see here, your file is what is the data that you have. Now, if you want to have it in a structured manner, you can create a data table component with it. In this, you'll be able to, if you want to explore data, you'll be able to see that here. And then if you want to add logistic regression to it, add different test and scoring techniques, create a confusion matrix, and then say create a scatter plot, it's all very easy and you can do it one by one. It has a lot of interactive data visualization. Say you have a visual workflow created like this, wherein through your file, you're once looking at your data, and then you directly add a scatter plot component. When you add a scatter plot component, Orange on its own converts your data from the file directly to a scatter plot. In this case, this is how the scatter plot looks like. Now, say you want to explore, you had a threshold somewhere here, and you want to see why are these data points above this threshold. In that case, you would just select these data points, open your data table here, and you would see the selected data points. You've selected things here, and you'll be able to see what are the data points in a tabular format here. What are the details of the different columns? And even do it vice versa. You select a few data points here and see where does it lie in your visualization. This is wherein what I was talking about earlier of seeing the predicted values if they're following the trend you're trying to set or not. This makes it very, very easy to do that. Additionally, it is very interactive. So you could have multiple ways of looking at the data as well. For example, here you could do a data file. You could add a classification tree and then have a classification tree viewer to create a visualization like this, and then also add a scatter plot. So this way, if you add a color to different kind of branches of the tree that you want, you'll be able to see the scatter plot in those colors. So you see, interpretation, the same data can be represented using different forms. It is up to you as to what are you trying to highlight in your data set. Do you want to understand something related to the distribution in the scatter plot, or do you want to show the decision making behind things? So based on the way you want to interpret it, you have the capability to do that as well. Additionally, it has a very clear workflow design. So if you add a file, this is how the interface looks like. So one more thing, so Orange, if you are somebody who's very heavy into coding and that is what you prefer, you can import Orange as a library in Python and use all of these capabilities as code in your Python code. If you're somebody who's new to this space, then you can directly download for Win and Mac both. You can download Orange on your PC and use this in a drag and drop fashion. So it is going to do the same capabilities. If you want in your code, you can use it as a library, or you can use it here to better visualize your code and do modifications here. It is very, very beginner friendly. So even if you don't know a lot about different tools, for example, you drag and drop a widget here of file and you want to calculate different distances. Now, in order to have one more widget, it has to be compatible with the previous widget so that correct information can be interpreted by the next widget. So once you click here and like create a line out of it to create the next component, it will give you a suggested list of compatible components with the previous one. So here you see there are like, since we calculated distances, now we could have a distance map, a distance matrix, or if you want to do other classification, different visualizations, you can have that. So it tells you what is the next component compatible with your current component or widget possible. And it has really good visualizations. So you don't have to spend any time in order to even understand what is the correct visualization that represents my data well. You can just drag and drop multiple kind of visualizations, see how they look, and see what visualization actually gives you a very, very good kind of way to interpret and display your data, and then choose among those. So here, if you see, this is a box plot, this is a normal distribution, this is a heat map. Based on your use case, based on the domain you're working on, or the exact project you're working on, it might be a case for some, the heat map might be better, for some, the distribution or the box plot might be better. So that is a decision up to you, and you don't have to really put in a lot of effort in order to create these different visualizations. Now, many a times, we get stuck due to a number of choices, especially when you have data with a lot of features. At that time, how do you choose the optimal feature pair to visualize data and to gain maximum information? That is wherein intelligent visualization comes to the rescue in Orange. So with Orange, there are different plots, and in Orange scatter plot, it is called score plots. So if you have multiple features, you will have different scores associated with each of the feature pairs. So this data has so many different features. Now, what is in your X and Y, what should be the pair of features that you should use? That is something you can see here directly in the rank projections for the scatter plot. And then you can see what is the score of distinction between creating the clusters. So to have very separate clusters, what is the best feature pair to use? This is something you can also use to your advantage to generate insights, or while creating the machine learning model to understand different weights that you will apply to different features. So this is an interpreted way of how I use it. The Orange documentation doesn't say that you can use it this way, but I found it very useful to understand what weight each feature should have, because it is going to directly impact your data set. So it is good to see what is the relation between features, which features are more highly correlated, which are less highly correlated, and use that to your advantage and decide weights for your model. Also, it is good for reporting. Once you have everything, you might want to see different reporting features, and Orange has that inbuilt as well. Let's look at a quick demo of using Orange. So in this case, I have my data set, and I have now included it as a file. Next, I'm now applying k-means to it. With k-means, I'm trying to see a scatter plot, a box plot, and also I'm applying MDS to my k-maps. And then through the selected data, I'm saving the data. In this case, one more thing that I'm doing is for my MDS, if you see here, this is the MDS optimization that I'm doing. Now, I have set the number of iterations to be 300 here. I'm using the initialization to be PCA. You can have PCA or random, and a refresh of 25. Additionally, like symbol size, opacity, jittering, all of this is like for the visual aspect of it. And this is the MDS optimization parameters that I'm putting in. And also here, if you see with k-means, I'm adding, if you see, I have two options, either for it to be fixed or to have Orange calculate the optimal value of k for me. So that is also possible here. So once I do this and once I click on start, it'll create what is the best way of visualizing it along with the k-means number of k clusters that I have. Now in MDS, the additional thing that I want to do is to identify what is the k value. One was that I have it to be fixed here in the previous case. Now, instead of the fixed, if I go ahead and do it for from, now between 2 and 8, I want to see what is the right one. So what Orange does is it calculates the Silhouette score for each value of k. Silhouette score is Sellout score is calculated based on the value of the distance between 2 points in a cluster, and based on a k value, where would a point lie in cluster 1 or cluster 2. So the Sellout scores for each value of k is calculated. Since I did 2 to 8, it is 2 to 8, and the Sellout score for each is calculated. With k equal to 3, I see the Sellout score is the highest here. So that means that is the best k value in order to segregate my data. And that is how you can directly make use of Orange in order to create quick decisions as well while building your models, and also parallelly have inbuilt visualizations without any extra coding effort. Um, as a last part of my presentation, I would like to share a use case. Orange has been used in space as well. In the Hayabusa 2 asteroid sample return mission, it was used to identify and analyze data. This is a small part of what the Orange workflow looked like. So here, if you see, they had the asteroid information, then using reshaping techniques, using different things that are known very commonly like k-means, different spectra are calculated, the ratios, different workflows. This is a very small part of the big asteroid mission, but this is so interesting. Orange is so powerful that it was also used to analyze big data sets like an asteroid mission data set. So since it was used in space, why don't you use it in your projects and use it for the power of empower for the power to have interesting insights and data through your projects. A few references and attributes of my presentation. So the very first one is the orange.biolab.si. You'll find a great documentation, video tutorials as well. And if you're new to this, I just suggest download it and use the drag and drop feature to understand machine learning concepts better as well. And the second is a book that I used when I was initially studying about different analysis, big data analytics tools, and data science in general. So yeah, that is about me. That's the end of my presentation. These are all my social media links, and all the best to everybody at the hackathon as well.
Let's give a round of applause to Drishti.
Thank you.
I think we can open it up to some questions. I can start.
Yep.
I've used Anaconda in the past, and I've always seen the orange application there, but I've never clicked on it. Would you recommend Anaconda as like the best way to download Orange and use it?
So I personally did not use Anaconda to download Orange. I directly downloaded the plain web, like the desktop version through the website. But you can use Orange inside Anaconda if you're already building your project in Anaconda.
Okay.
Yeah.
Thank you.
Also, I would encourage everybody, even if you already have your model ready, since we are like a few hours into the hackathon, but you might want to also look at uh, just understanding your data. Maybe you're creating something specific, but many a times I've seen that I got very interesting insights just by visualizing data. And since it is with like a few clicks, it doesn't take more than 5 minutes for you to try out different visualizations. You will maybe identify a very interesting insight and maybe completely pivot your project to that insight. So it might lead to like very different interpretations of data. Yeah, so in the chat, I see like John has posted about PIP to be an option as well. Yes, so Orange is pretty well known in the research and scientific world space, not that much into the corporate space. So it is available almost everywhere, and it is a very well maintained project. Biolab, I think they're pretty well funded as well. So they maintain it pretty well. There's a good documentation and everything around it.
Great. I thought it was really cool how they just automatically give you that ranking of the features so that you
Yes,
can choose.
yes. So something that you would otherwise have to write a big script for it, it's done for you within a second.
All right, unless there's any more questions, I want to give another thank you to Drishti for taking her time out of her Saturday to be here and talk to you guys. Um, like she said, she'll be around tomorrow to help judge your guys' amazing hacks. Um,
Yeah, it was a pleasure speaking to everybody and sharing my knowledge. Thanks for having me.
Thank
thank
you.
you.